Very warm welcome to the second video on my YouTube channel. It's roughly a year since I put my first YouTube video up on this channel. Back then, it was just after Las Vegas 2024, where I won the Microsoft Excel Collegiate Challenge. This year, now 1 year later, I competed as well. I finished only fourth in these competitions, but we will still be looking in today's video on the final case. I do my Sudokus 20 at a time, because I think it's quite an interesting case. I didn't do really well on it on the final day in the actual competition, but that's already passed by now. I just want to show how I would solve it. Just by now, we haven't yet gotten the final case and answer file, so I may or mostly did with my own solves and watching the live stream, create my own answers file. There isn't really an answer for bonus 2 that's shown in the live stream, so I don't have this filled out. And there's nobody got any points at level 7, but I did it already previously before this video, so I have answers for level 7, and I think that the answers for level 7 are right. I match the example and all 3 hints, so I suppose that's right. But I think we can start right into it. I have all of my lambdas here ready. I have our robot ready here. So I think we can start. I don't really like the bonus questions, so I will start with the levels. The first level is something you can also do without indirect, but I think for this first level, especially in the given circumstances, you really want to do it with indirect, because the deciding effect of the knockout phase, and also, to be honest, it's much easier to do it with indirect and only like native Excel functions. So you can see everything that I'm just doing here is creating an indirect that's referencing this cell location with in the given tab that's called like with the use paper, and take everything that's before this weird symbol, like the string. That's more or less the name of the Sudoku. And starting with level 2, we kind of need a bit more preparation, and I'm going to do this in a simple way. I'm going to create tab through all of the different newspapers and create named ranges that are called underscore and the number of the newspaper. And as soon as I'm done with this, I will then go and create a named range, or not a named range, that's what I'm currently doing. But afterwards, I'm going to create a switch lambda, more or less, that can that takes an input n whatever and gives me the named range for what we need. I think for the amount of Sudokus and newspapers we currently have with 20, I think this is the fastest method. I also did something pretty similar during the competition. When I thought about what's like the fastest way of solving this, I think for 20 this is the fastest way, because if you would do it with like a bit different way, and I can show it briefly afterwards, at more or less merging everything from all the 20 Sudokus or 20 newspapers into one single page, and create like look up columns and stuff like that. I think this would be slower for the simple reason that it's the Sudokus are in different places every time. If the Sudokus would be in the same spot every time, I think this would be or even if they are not 20, but oh my god, I mislabeled this from 20 to 12. That's something that shouldn't happen, but it happened now. But we can now call this 20 and it should be fine. And then we can simply create a lambda that takes an input and creates a switch statement that uses the A. And I'm now going to write NO. Should give me _0 and so on. I will make it a bit faster by clicking F9 on here. So now all I need to do is enter here the given numbers. I think you could do this a bit faster, but I'm going to do it like the old style way, and doing it old style is maybe a bit wrong, but the simpler way of doing it all manually, because as mentioned previously, 20 isn't like too huge of a number, so you can completely do this. If it would be a higher number, there would be alternatives that might be a better approach. Also, I think Pieter, shout out to him, he won the final competition. He did something similar-ish. He didn't copy or didn't create like named ranges, but what he did was he copied everything in the upper left column. I'm going to save this lambda right here and as underscore select. And now when I'm doing this, I get like the entire newspaper. And the other thing that's a bit annoying is like this R1, C9 column references that are simply annoying. I'm going to convert them into proper addresses. So A1 instead of R1, C1, and row is equal text after row and text before. If you know regex, you would be faster. I don't know regex, so I'm not faster. So that's R, and now I only need RC4, and I get like the row column references. I will also make this lambda that will be called converting. Underscore is more or less my own definition of how I call my lambdas. So now everything that I need to do is to put a private lambda from myself, index rcref, which takes either an rcref or an Excel address and converts this on an array in an index, more or less. So it takes one value, one array, and gives me the output. So that's all I need to do for this level. And I'm getting ref errors. That's not good. Did I make an error when selecting? Yeah, it seems that okay. I did some weird error here. I think something like this might be the reason. And now if I save you, copy you down, all of the right answers. And now I've also fixed my select lambda, which would have been a bit bad afterwards. Now level 3 is asking what is the sum of the numbers in the given column of the Sudoku puzzle in the given newspapers. Again, pretty simple with our setup. We are selecting the lambda. We are asking for a column here, so we want the proper index this time, and we just want to get the column which is text after plus null. Something I did in the competition was I supposed that this C1 is like a proper Excel address and not an indicator of the column. So I converted this C5 into a column, which is of course 3 because C is always the third column. And then I decided, oh, I might need to take the row. I took 5. And all of that added up in terms of time, which was most of the reason why I did pretty bad on this case. But nothing too bad. For level 4, we are asking, we can look at one of the Sudokus. We have these red and blue kind of things right here. And what we kind of need here is to determine what is the input, or what is like in the given cells. There is a pretty easy, if you get it, way of doing this with formulatic way. You just kind of need to only multiply, divide by 3, round. You need to divide the current row by 3, round down, multiply, round up, multiply by 3, and add 1 or subtract 1, something like that. I did try this during the competition, but I couldn't wrap my head around how to do it like properly. So I'm not doing this anymore right here. I'm doing the way I went in the competition like afterwards. 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is H2. And creating like a simple lookup named range that's always pointing towards like in the center. So if you're here, the center is B2, and then I can get off the radius of 1 around this. If we are here, we want to take H5, which is this cell. And if we are here, we take the same cell, and it's E5. I named this lookup. And now all I need to do is convert this right here to our index RCRef in lookup. So we get now H8. I have an offset RCR lambda, which is more or less a simple do whatever offset does, but do it not volatile. Volatile functions are a topic for another time, but I don't really want to use volatile functions, so I'm doing like my lambdas. You could do most of this with offset or indirect, straightforward, but it is more or less the same. And I'm taking this right here, and if we now decide to sum everything, then we are getting null, because there's some weird issue that some of this might not be numbers in terms of this kind of thing, but if I add 0, then I can sum them. So now we have solved level 4 as well, and we can move on to level 5. In level 5, we are asking what possible values could go, that could be in the given square. So we have one given square. First of all, we take simply what we have previously and take away the sum and wrap you in a let statement and call you square. I think, yeah, let's also to call you. So now we have all the values that are like in the given square. And in addition to that, we kind of just need this solution, but a bit different. So I'm building it myself. For the row, we want index, select the newspaper. We are looking at the row, so we want RCRef to row. Same thing, you could do rows indirect, but I don't want to use indirect. Of converting this square, I take everything. My RCRef converter has a small issue. It gives me an array, and if I take an array, it doesn't work. So I need to do this 1-1 or write an add before. But if I write an add before, Excel always asks me if this is an error. It's not an error, but Excel thinks it's an error, so I'm not writing it there. Yeah, I think that's looking good, but I need to copy everything from here. So index from select here. That's fine. I need the column and get rid of this and do asref column. And now I can give me like row or column. That looks good. And now I can to call unique to call vstack rcl square. Yeah, maybe if we to call ignore the errors. So that are now all the values. We see there are now 8 values, including a 0 in there. And now all we need to do is we filter a sequence of 9 and include, we are checking if the sequence of 9 appears in this given array. Appears in array is more or less this is a simple lambda. That's just taking appears in array is just an X match and not is error X match. So nothing too complicated, but it's pretty useful in some of the circumstances. Since we are doing a sequence, we already have everything like in sorted order, so we do not need to do this again. And now we have the final answer and image everything. Level 6 for the Sudoku puzzle in a given newspaper was the sum of the possible values of all the empty squares in the puzzle that only have one possible value. Yeah, that's more or less exactly the same thing, but for all of the cells. I am going to delete you and you. So now I get, yeah, of course, from some random array, one random cell. I think it's time now to put you in a lambda. I will call this Sudoku and cell. The Sudoku should be everything, not just the selected part. So I'm replacing everything where we selected that from here. And the cell should be also not the converted part, because we are going to take this seriously and don't use the converted part anymore. And also, since my RCRef to call or RCRef to row, I can take like everything, including RCRef addresses and Excel addresses. That's looking pretty good. If you're going to select this and A1, we get a 9, which might be the right answer. So I think it works. So I'm going to save this lambda as possible values. And now all I'm going to do is we need a let of all cells. For this, I'm using a lambda that's creating the RCRef coordinates. No, maybe let's start with let Sudoku is gleich select this and coordinates is gleich RCRef coordinates from Sudoku. So those are my RCRef coordinates. I am going to call you, so I have you in one column and not splitting up. In addition to that, I'm going to map now all of my RCRef columns with a lambda that says R, and the lambda is not a lambda, but possible values of Sudoku with our given cell. this would now give me a calc error, because this would give me now like an array pair for each of the given values. It would give me an array. So I'm going now right here and here. Possible values are all of this, and if the possible values, if first of all, if index ref in with a in S, so is equal 0, then we look at the possible values, because if there's already a value in there, we do not care about the possible values that could go in there. And if this is null, so if this is 0, then we look at if count from p, so the amount of numbers that are possible is equal to 1. If this is the case, then we simply take p. Otherwise, we look at 0. In this case, we look at 0 as well. So I think this should now work. And yeah, if we sum everything, we get 41, which is the right answer. And we are done. Yeah, for level 7, it's marked as very hard. I don't think it's too hard if you kind of get the concept and have like this setup pretty valuable, because all it asks for is like solve the entire Sudoku, and with this setup, all Sudokus are solvable. I'm going to do this with data table set up more or less because I think it's much easier to do it. And like my approach now is, if there's a data table, if this is the last level, use a data table. If this is like the last dimension you want to work in. If you are like an earlier level, you might want to stay single cell or easier single cell, because you might want to go for an additional dimension that you can get with the row color. So all I did here is like I selected everything and two-rowed it, and now all I need to do is more or less take this solution right here. Yeah, maybe I'm doing a two-row of RCRef coordinates from selecting this. So we have now the coordinates and the given value right here. And if this is 0, then let Sudoku ist gleich wrap rows from this by 9. And I need to check if this is the right thing, because I never remember if wrap rows or wrap columns. In this case, wrap rows is the right answer. So this is the Sudoku, and we can now use possible values of the Sudoku and of this cell right here. And we get 9, which is fine. But we wanna map everything right here. So we get this is of course a calc error. Lambda a, let possible values. No, we are in here. This is the possible values. We are mapping A2. I think we now have like an array. If count of p is equal to 1, then give me p. Otherwise, and otherwise 0. Not an A. I think this should be fine. And now all we need to do is to look at this. If this is gleich 0, then give me this. Otherwise, take the previous thing. So you see all of them stay the same, but here in the value previously unsolved is now 3. And if we move this a couple of times down, we forgot to lock cell references, something I like to do it in the competition as well for a few times. All we need to look is now sum of minus minus. This is unequal to this. Copy this down. You see, I've copied it too many times, maybe for bit performance optimization. To this, if this is 0, then 1. Otherwise, this. And now I'm going to take the product, which is 15,120. And if I now create a simple data table that's looking at the answers and takes a bit to calculate. Maybe I should have saved previously. No, it's now finished with calculating. I can input all of my answers and get all of the right answers. And now I'm with 26 minutes and solved the entire case without bonuses. But I think I still have time to do the bonus questions. So all I want to do is sequence. I'm starting with bonus question 4 because I think that's the easiest. All I want to do is select this and sum it everything up. And right answer is 4149. What is the score of the newspaper with the highest scoring name? For the bonus questions, we had like this more or less setup description previously, which had like this setup, and I think a few of the data is actually written somewhere here, but this specific page here is nowhere written here, and here it tells you that the newspaper name is always in the cell B2, so you kind of need to simply do an indirect of this and B2, and you get like spreadsheet special. Yeah, of course, locking cell references. I like to forget about that. Now you have like the difference. I have a split lambda, you see what it does. And I'm going to X match you against the entire alphabet. So I get like the position in the alphabet. And now I am summing everything up. Yeah, that's fine. I just need to do an if error 0. What is the score of the newspaper with the highest scoring names? That's the MECC. So it's 233, not 50. Not replace it with the points, because that would be funny as well. Each puzzle is labeled as easy, medium, or hard. Assuming easy puzzles are worth, so we kind of need to look at this position. There are 6 possible positions for all of the newspapers or Sudokus, where like the name and or the thing is written. But in fact, you kind of have here in level 1 all of the positions ready. So all you need to do is do an indirect of this. All you in fact need to do is take this formula and change this text before to a text after, and you get like all of the answers. Underscore count is more or less a simple most of, and now you can do easy puzzles are worth 5 points. medium puzzles are worth 7 points and hard puzzles are worth 11 points. So we are getting 130 points, which is the right answer. I really did this case in the competition and afterwards, and now for the third time. It was just now in my head that I realized, yeah, that's simply the way you can do this. So this is such an easy trick that you do not think about. But I'm wondering if someone thought about doing it this way during the competition. And maybe that's also the reason why it's bonus one. So if we are looking at which author is most prolific, has been credited as the author of the most article across all 20 newspapers. Articles are things that are written right here. They are written either in B8 or B19. So all we kind of need to do is B18 author names, and that's also something that's written on here. All of the cell addresses, so I'm going to write them down from here, is B19, K19, and T19. And all now we need to do is an indirect of this and this. And now I'm finally not forgetting to log my cell references. You see already there are like a few authors. I am now calling everything right here. Maybe let's move it over there and count by Chris Webb. Yeah, of course, this will be marked as like the wrong answer because I couldn't kind of figure it out if this is the right answer. But as you've just seen, this is the right answer at bonus 3. I tried to do it, but I struggled during the competition because of a stupid mistake. But that's fair. We have like all of the names right here. So we can work with them. And all you need to do is you need to determine the number of uppercase letters and the number of lowercase letters. So first of all, we want to split this. Let split is equal to this. And then we want to, first of all, determine is letter. In order to be a letter, the thing needs to appear in the alphabet. So now we get like a true or false. Everything, yeah, we see this does not appear, and then we can filter S by is L, and we get like only the letters. And now we can look at, we have like the letters, and now we can look at is upper. In order to be an upper letter, we need to map. I don't know if you really need to map it, but I think it's fine if we do lambda A exact A and upper A. If I entered too many functions, yes, because this needs to be is upper, and we see now the S is an upper letter and everything else is like a is not. So we can now restack sum of minus minus is upper, across length of is upper minus this thing right here, which should give me the lowercase amount. Am I still in the map, or why are you giving me length of Yeah, I think I just need to do a sum right here because is upper is in a way. No, of course, I need to do with L 1 and 6. Yep, and not V stack but H stack, so we can copy it down. And now all we need to do is we need to sum this and sum this and multiply here two, and we get 15,860. I have no idea why you're calculating the data table in the background and crashing Excel, but 15,860 is the right answer. And yeah, we get it now as well. Yeah, I think I've solved now the entire case in 35 minutes. I couldn't even figure out the entirety of level 6 in the competition with 40 minutes, yet alone most of the bonus questions. And in addition to that, I talked here as well. But yeah, really congratulations to Pieter again. Really deserved victory. You competed with me 4 years now, 3 years, sorry, in Tucson for the first year, where you missed out on qualifying for the big final, but qualified for the semifinals for your first time. Then last year being second, already a strong opponent, and this year you really showed everyone that you deserve to be the champion. So congratulations again from my side. You really deserve this victory. I'm hoping to come back next year as well, and really hope to maybe put up a few more YouTube videos this year, also showing and explaining maybe my lambdas or anything in addition. So yeah, I hope you liked it, and see you next year.